Hello everyone, welcome to this short Prideway refresher course. This session will continue with standard operations, including value stream maps, standard work combination sheets, and percent load charts. We will also recap root cause analysis. A value stream map is a visual representation of a process from start to finish. A value stream map can either demonstrate and help you to analyse the current state, or can also be used to show what the future state could look like after improvement works have taken place. Here's an example of the value stream map the KPO team created for patients calling the appointment centre. As you can see here, value stream maps include the individual cycles, and above you can see the KAIZEN bursts of wastes that have been identified through observing this process. Note how the colours of the KAIZEN bursts match with a particular cycle, so it's clear to see which wastes relate to a particular part of the process. At the bottom of each cycle box, we have the timings we documented during observations. Note also the push-pull arrows behind the triangles, which represent the flow. Push arrows demonstrate that the next step in the cycle is not yet ready for the work, but the work turns up anyway. This is where you get wait states and batching. Whereas pull arrows show when the next step in the process is ready for the work and pulls the work through the system. This is where you have no batching. Here is the template value stream map, which you can use or feel free to draw your own. To fill out the process boxes of the value stream map, you will need the information from your observation forms. Don't forget that the title of each box should be from the perspective of the patient where possible. For example, I booked in at reception or my blood is taken. Beneath this, the individual steps of booking in at reception or having my blood taken can be documented. Note the operator symbol in the bottom right-hand corner of the box, which indicates how many operators are involved in this particular part of the process. For the data boxes at the bottom, remember the CT or cycle time box relates to the mode or median you noted on the cycle time observation forms. PT or processing time is the hands-on time during the cycle of work. For the value and non-value added boxes, remember these questions from session 1. After considering these questions from the perspective of the patient, it's up to you to decide how much of what you observed was value added or non-value added for our patients. It's likely that people will have differing opinions on how much they feel is value added, but as long as you can justify why you think something is value added, then this is fine. Don't forget to always start at 0% value added and work your way up to identifying what is value added, rather than starting at 100% value added and reducing this down as you identify what is not value added. For this example, the KPO team have decided that 58 seconds of this part of the process were value added and 13 seconds were not value added. To work out the percentage, divide 58 by the total time of 71 seconds, which gives us 0.816. Multiply this by 100 to get 81.6, which will then round up to 82% value added. This means that 18% of the total time was not value added. The spaces in between process boxes is where you'll need to record any wait times you observed and documented on your lead time observation form. So here, the patient was waiting for 1 minute and 20 seconds between finishing booking in and being called by the nurse. Here we have the summary boxes for the value stream map. Your lead time will be the total of the cycle boxes and the wait times in between. The processing time will be the total of all the hands-on time from the PT boxes under each cycle box. Add together any changeover time from the cycle boxes and include the total here. If there is no changeover time, then this is fine. Here you will add together the individual value-added times. The total of these value-added times, subtracted from the overall lead time, will give you the total non-value added time. We can see here that 58 seconds were value added. So out of a total of 5 minutes and 58 seconds, this means 5 minutes were not considered value added time. You can then calculate the percentages. Remember, the WIP is the number of patients or products at or in between each step, the work in process. This number is recorded in the triangles between each of the cycle boxes. Add KAIZEN bursts to document any wastes you identified. Examples could be walking or waiting periods or duplication of tasks. We will now recap the standard work combination sheet. The standard work combination sheet helps us to compare how work is currently done versus TAKT time. It's also a helpful way of identifying walking and waiting. The standard work combination sheet shows the work of one operator and uses the values from your cycle time observation forms. Here is an example of a standard work combination sheet. Like you would for any graph, you need to determine the increments for the graph. This graph also needs to include the TAKT time and the total operator cycle times. Remember to draw a vertical red line depicting the TAKT time. This will allow you to compare your observed timings with TAKT time, which, don't forget, is the ideal cycle time. Enter a brief description of each step, the timings, and draw the corresponding lines in the graph area as seen here. And don't forget to refer to this legend to determine which type of line to draw. And lastly, complete the information boxes like you did for your lead and cycle time observation forms. Now we'll recap the percent load chart. The percent load chart helps us to balance the work between operators and indicates where bottlenecks are. It includes times from your cycle time observation forms. Like you did for the standard work combination sheet, you need to determine the increments for your graph. This time, these will be on the left-hand side, and your red TAKT time line will need to be drawn horizontally instead of vertically. At the bottom of the chart, you need to write out each operator's title, their cycle time, and draw the corresponding bars. Don't forget to fill out the information boxes at the top. Lastly, you need to calculate the number of operators needed by taking the total of the operator cycle times and dividing this by your TAKT time. Here we can see the operator cycle times total 3 minutes and 8 seconds, or 188 seconds. Dividing this by our TAKT time of 4 minutes and 4 seconds, or 244 seconds, gives us 0.77 of an operator. Obviously, we cannot have 0.77 of a person, so this will be rounded to 1 operator. Despite this calculation saying we need less operators than we actually have, we do need to take into account the skill mix of the staff. And lastly, don't forget to convert minutes into seconds to make it easier to calculate the number of operators needed. So now we have a variety of standard operation tools which document our current state. This baseline data allows us to compare against any future improvements. We will now briefly recap root cause analysis. To carry out root cause analysis, we can use 5 whys, affinity diagrams, and fishbone diagrams. It's important to have a subject matter expert present or contactable when carrying out any of these root cause analysis techniques, as he or she will be able to provide factual answers rather than the root cause analysis relying on assumptions. Have a look at this example of 5 whys. 5 whys is a tool which can be used once a problem has been identified, whereby why is asked as many times as needed until the root of the problem becomes apparent. Affinity diagrams are very effective tools at allowing us to look for relationships between ideas and allows all team members to include their input. Remember to brainstorm your ideas, write them onto sticky notes, and then sort them into themes of similar or connected ideas. If you're watching this video and need to complete your assignment for session 3, you'll need to create your value stream map and use the value stream audit tool to make sure you have included all of the necessary information. You will also need to use data from your cycle time observation forms to create standard work combination sheets for each operator in your process. Use your cycle time observation forms again, this time to complete your percent load charts to show the work of each operator. And lastly, you will need to carry out a 5 whys or affinity diagram for a problem within your area and then complete the root cause analysis form. This is the end of the refresher course. If you have any questions, please contact your coach or email us at sm-kpo.